The James Webb Space Telescope, JWST, has opened a new frontier in our understanding of the universe with one of its most extraordinary discoveries to date. The farthest galaxy ever observed, JADES-GS-Z14. Situated a remarkable 13.5 billion light-years away, JADES-GS-Z14 is a distant galaxy seen as it existed only about 350 million years after the Big Bang. This discovery is nothing short of revolutionary because it allows astronomers to observe the universe at a time when it was still in its early stages of evolution, an era that has remained largely inaccessible until now. JADES-GS-Z14 offers us a rare glimpse into a time when the cosmos was still emerging from the primordial chaos and slowly starting to form the galaxies, stars, and structures that would eventually become the universe as we know it. The James Webb Space Telescope, launched in December 2021, was designed with one primary mission: to explore the distant universe and answer questions about the cosmos that have eluded us for centuries. JWST is a highly advanced space observatory that operates in the infrared spectrum, which allows it to see through the cosmic dust and gas that can obscure distant objects when viewed through optical light. This ability to observe in infrared is crucial because it enables Webb to study the very first galaxies, stars, and other celestial objects that formed during the earliest periods of the universe's history. As the universe expands, light from these distant objects becomes stretched and shifted toward longer wavelengths, or redshifted. This is why infrared observations are so vital. They allow Webb to detect the faint signals from these faraway galaxies, some of which have been traveling across the cosmos for billions of years, carrying valuable information about the early universe. JADES-GS-Z14's discovery is part of a larger effort to study the cosmic dawn, the time when the first galaxies and stars began to emerge, only a few 100 million years after the Big Bang. Before this period, the universe was in a hot, dense, and opaque state, and it wasn't until this era that the first sources of light began to emerge, gradually illuminating the surrounding space. This epoch, known as the Epoch of Reionization, was a pivotal moment in the history of the universe. As galaxies and stars formed, they began to ionize the surrounding hydrogen gas, making the universe transparent to light. JADES-GS-Z14 represents a glimpse into the early stages of this process, revealing how the first galaxies began to take shape. Observing galaxies from this early period is crucial because it helps scientists understand how the first cosmic structures were formed, and how matter began to come together to create the building blocks of our universe. One of the most striking aspects of the discovery of JADES-GS-Z14 is the implications it holds for our understanding of galaxy formation in the early universe. The galaxy is being observed in a phase when the universe was still young, but it appears to be far more complex than astronomers had initially expected for a galaxy from such an early time. Its properties suggest that galaxies may have formed earlier than previously thought and that the processes that led to their formation were likely more sophisticated than the simple models once imagined. The discovery of JADES-GS-Z14 challenges previous assumptions about how galaxies evolve in the early universe and suggests that they may have developed through more intricate processes than initially believed. This raises new questions about how the conditions of the early universe allowed for the rapid formation of galaxies and stars, and whether these processes were uniform across the cosmos or varied in different regions. To fully appreciate the significance of this discovery, it's important to understand the technology that enabled it. The James Webb Space Telescope is equipped with a suite of cutting-edge instruments that allow it to peer further back in time than any previous space telescope. The heart of Webb's ability to detect these distant galaxies is its large mirror, which is 6.5 meters, about 21 feet, across, significantly larger than the Hubble Space Telescope's mirror. This large mirror allows Webb to collect more light, enabling it to detect the faint signals from galaxies like JADES-GS-Z14, even at such vast distances. Additionally, Webb's infrared instruments, such as the Near-Infrared Camera, NIR-CAM, and the Mid-Infrared Instrument, MIRI, are highly sensitive and capable of detecting light from objects that are billions of years old. Because JADES-GS-Z14 is so far away, the light from this galaxy took more than 13 billion years to reach Webb, allowing us to observe it as it was in the very early stages of the universe's evolution. The discovery is not just a testament to the capabilities of JWST, but also to the ingenuity and persistence of the scientists who designed the telescope and planned its mission. By studying galaxies like JADES-GS-Z14, astronomers can investigate the conditions that led to the formation of the first stars and galaxies and learn more about the processes that shaped the early universe. This knowledge could, in turn, help scientists understand how galaxies like our own Milky Way came to be, and how the universe evolved from a hot, dense state into the vast, complex system of stars, planets, and galaxies that we observe today. The discovery of JADES-GS-Z14 is a key step in humanity's quest to understand the origins of the universe, but it's just one of many exciting revelations that Webb is expected to make. The telescope's powerful instruments will continue to push the boundaries of our knowledge, offering new insights into the formation of galaxies, the behavior of black holes, and the nature of dark matter and dark energy, two of the most mysterious and pervasive forces in the universe. As Webb continues to observe the distant cosmos, it is expected to uncover even more distant galaxies and provide us with a deeper understanding of the history and evolution of our universe. Looking ahead, the implications of JADES-GS-Z14's discovery are far-reaching. Not only does it challenge existing models of galaxy formation, but it also opens up new avenues for research into the early universe, the processes that led to the formation of stars and galaxies, and the role that cosmic reionization played in shaping the universe's structure. By studying galaxies like JADES-GS-Z14, scientists can gain a better understanding of the conditions necessary for life to emerge and how the universe's early phases laid the foundation for the complex cosmic systems we observe today. Ultimately, the discovery of JADES-GS-Z14 exemplifies the power of science and technology to answer fundamental questions about the universe. As we continue to explore the distant cosmos with the help of the James Webb Space Telescope, we are bound to uncover more answers about the universe's origins and its evolution over billions of years. And, as we learn more about the first galaxies and stars, we move one step closer to understanding not only how the universe came to be, but also our place within this vast and awe-inspiring cosmos.